Lesson 1.2, graphs of equations. We'll start by determining if the ordered pair, the solutions for the equation. So for part A, okay, for A parts, you want to plug 1 in for x, 3 in for y. So is 3 equal to 8 times 1 minus 5? 3 is equal to 3. So that works. So yes, 1, 3 would be a solution. B part is 4 equal to 8 times negative 2 minus 5. So that's what, negative 16 minus 5 is negative 21? Is that right? So that's not equal. The answer would be no. Anytime you're plugging in and you're checking to see if things are equal, and if they're not, put a slash through that to show that that's not equal. You don't want to leave an equal sign there. So if I graph this line, this point will be on that line, this point will not be on that line, right? That's what that means. Okay, we're going to sketch the graph of y equals 2 minus 3x. You may want to use the y-intercept and the slope, but I'm going to use t-chart. I'm going to plug in negative 2, negative 1, 0, 1, and 2 for x and see what I get for y. So if I plug in negative 2, what do I get? 8. So it would be positive 6 plus 2, or yeah, 6 plus 2 would be 8. Negative 1 would be 5. If I plug in negative 1. 0 would be 2. 1 would, what? Negative 1. And what, negative 4? Wait. Negative 4? What? Okay. So plot the points. Negative 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 5. 1, 2, 3, 4, 5. 0, 2. 1, negative 1. 2, negative 4, 1, 2. And those should, if they're not all in a straight line, because you know that's the equation of a line, then you got a wrong answer. This is easy stuff, right? Okay, can I go to the next slide? Okay. So to sketch this graph, we'll do the same thing. Use a t-chart. We're going to do negative 2, negative 1, 0, 1, and 2. If I plug in negative 2, I get 2. If I plug in negative 1, I get negative 1. If I plug in 0, I get negative 2. If I plug in 1, I get negative 1. If I plug in 2, I get 2. Is that right? Do you see a vertex in those points? Look at those points. Do you see a vertex? You know this is the graph of a parabola, right? See a vertex? Do you see symmetry? Okay. Graph those points. Negative 2, 2. Negative 1, negative 1. 0, negative 2. 1, negative 1. 2, 2. You put a curve through those points. Next. Okay, we need to find the x and y intercepts. How do we find the x-intercept? So we found the x-intercept. What is your y value when you cross the x-axis? What is the y value when you cross the x-axis? What? 0. So let y equal 0. So to find the x-intercept, let y equal 0. So if you let y equal 0, solve your equation for x. So we need to factor out a negative x. And if you do that, you get x plus 5, right? Set each factor equal to 0. Negative x equals 0. X plus 5 equals 0. So x equals 0, and x equals negative 5. So your x-intercepts are 0, 0, and 0, negative 5. Right? When y is 0, what did I do? What did I do on this one? Okay. Put it in the wrong place. So it's negative 5, 0. That was a y-intercept. It's not the y-intercept, but that would have been a y-intercept to something if 0 is in the x's place. So y is 0. So negative 5 has to be where x is. Now we have to find the y-intercept. Y-intercept's much easier. So the y-intercept is 0, 0, and we should have been able to tell there that that's the x and the y-intercept. It just said to find the y-intercepts. We don't have to graph it. We can graph it to see if that's true, or we can just leave it. Okay, we'll just leave it. Why are there 2 x-intercepts and 1 y-intercept? Right. It's a parabola. So think about a U. Now, with a parabola, you'll learn later, if you don't already know, you can have, it will either cross it in 2 places, in 1 place, or in no place, right? You could have the parabola up above the x-axis. You can have it touching it at the vertex, or you can have it coming below, which would give you 2. And it can only cross the y-axis in 1 spot. And we're testing for symmetry. So what I want you to do is to turn to page 19 so that we can look, to keep you from having to write all of this down. On page 19, it shows you 3 scenarios where you have symmetry about the x-axis. This is on page 18, I'm sorry. Look at page 18 first. On page 18, in figure 1.21, that shows you a graph that is symmetric about the x-axis. The next one is about the y-axis. And the last one is about the origin. And what you want to do to test, if you want to use the, if you want to test for symmetry and plot less points to graph a line, if you put in negative x and you get the same answer, then it is symmetric about the y-axis. If you put in negative y for y and get the same answer when you simplify the equation, then it's symmetric about the x-axis. To test for being symmetric about the origin, you will be able to do, it says, if you replace x with negative x and y with negative y, then they're equivalent. So if both of them work. So can you look at y squared equals 6 minus x and determine if it's symmetric about the x-axis, y-axis, or both, about, which would mean about the origin? If you put in negative x for x, you're going to get a different equation, right? But if you put in negative y for y, it squares and becomes the same thing. So you'll get, so that one is symmetric about the x-axis. If you can put negative y in for y and get this, and simplify and get the same thing, then it's symmetric about the x-axis. Here's another way to think of it. A parabola has the x squared, which means it's going like this. And you know a parabola would be, if it is symmetric about the y-axis, symmetric about an axis, it would be about the y-axis. And that's the x squared. But if you square the y instead of the x, then it's going to be like a parabola. It's going to be flipped this way and be symmetric about the x-axis. That's how I keep it apart. So if I put in negative y for y and simplify it, do I get y squared equals 6 minus x? Does anyone not know what I'm talking about? Here's, just let's make sure. If I put in negative y for y and simplify that equation, what is negative y times negative y? Y squared. So if this, by putting in negative y, yields the same original equation, then it is symmetric about the x-axis. Why do that? Well, if I'm plotting points, I know it's symmetric about the x-axis. So if I put in, instead of going, it would be easier to plug numbers in to the y, right? Because it's symmetric about the x-axis. So if I put in 0, 1, 2, I don't have to put in negative 2 or negative 1 because it is symmetric. I should know by looking at the graph where those points are. So if I put 0 in for y, I get what? Zero in for y will give me 6 for x. What if I put 1? 1 squared is 1. Subtract 6. You get negative 5 is equal to negative x. X is equal to 5. Now what if I put Okay, so what we can do here, again, is just set up a t-chart. Put in negative 2, negative 1, 0, 1, 2. If I put in negative 2, and we'll see here that it's not symmetric. If I put in a negative 2, I get 4. If I put in a negative 1, I get 3. If I put in 0, I get 2. If I put in 1, I get 1. If I put in 2, I get 0. Here's the problem. We know this is a V, right? And this just keeps going down. So it looks like until these numbers start going back up, I'm not going to have enough points here to see what both sides of my graph. So negative 2, 4. Negative 1, 3. 0, 2. 1, 1. 2, 0. I'm going to have to keep plotting points or it's looking like a line, and we know this is not a line. So let's put in 3. I get 1. Let's go ahead and put in 4. I get 2. So 3, 1, 4, 2. There we go. That's enough. So this is symmetric, but not about the y-axis. It's symmetric about x equals 2, which, you know, really is not a big deal, but you can see where the numbers start repeating. The next one should give you 3, then 4, and so on. All right, one more. And this one's different. We are finding the equation of a circle. You have a point on the circle, 1, -2, and you have the center of the circle, -3, -5. We have to write the standard form of the equation of a circle. The standard form is x minus h, in parentheses, squared, plus y minus k, in parentheses, squared, is equal to r squared. So standard form of the equation of a circle. You saw it in geometry. I hope you saw it in Algebra 2. The center of this circle is h and k. The radius of the circle is the square root of r squared. It's the square root of whatever number's right here, because we don't normally see this number squared. So if this r squared is 32, then it's or 36, then it's the square root of 36, which is r. Square root of r squared is r, the radius. Okay, we have the center of the circle. It is -3, -5. We do not have the radius. So to find if we have a point on the circle and we have the center of the circle, what do we do with those 2 points to find the radius? Do we do midpoints? We do the distance formula, because you want to know how far apart are those 2 points, because that will give you the radius. So the radius is the square root of, use my shortcut, how far apart on a number line are 1 and -3? 4 units, right? From 1 to -3. If you're standing at 1 and you walk to -3 on a number line, you've moved 4 spaces. If you're at -2 and you move to -5, you walk 3, right? So that's 16 plus 9 is 25, and the square root of 25 is 5. The radius is 5. So now all we have to do is plug our numbers in. So we've got x minus a -3, x plus 3, the signs change. Y minus a -5, y plus 5, is equal to r squared. So it's 5 squared, not 5, but 5 squared, 25. That's the answer. Got it?
So you'll solve for x over 1.